Have you ever looked up at the starry sky and felt small in the face of the vastness of the universe? The enormity of the cosmos is a mystery that envelops us, a puzzle that has fascinated humanity since time immemorial. From ancient civilizations that look to the stars for answers to today's scientists using advanced technology, the quest for the secrets of the universe never stops. But what lies behind those bright flashes we see at night? Every star, every planet, and every galaxy has a story to tell. Are they just rocks and gas floating in the void? Or could they be the foundations of something much greater? Human curiosity is insatiable, always leading us to ask, what mysteries does the universe hold that we have yet to discover? Consider for a moment that the universe is a vast ocean of enigmas. Every wave that breaks on the shore of our knowledge reveals something new. But it also leaves us with more questions. Why do galaxies form? What lies beyond what we can see? Are there other forms of life in places we have yet to imagine? The history of cosmic exploration is a narrative filled with surprises and unexpected discoveries. Throughout the centuries, we have witnessed astonishing advancements. From Galileo's telescope to modern space telescopes, each advancement has allowed us to see a little further and with more clarity. However, as we expand our vision, we also encounter more questions. For example, how is it possible that the universe is expanding faster than expected? What is that mysterious dark matter that seems to be responsible for holding galaxies together? And not only that, there are phenomena that continue to challenge our understanding, stars that disappear without a trace, planets that orbit in strange directions, and even those that seem to be made of diamond. Each of these mysteries invites us to explore, to inquire, and to seek answers in a universe that seems to have more questions than answers. The fascination with the unknown drives us to keep investigating. What secrets does the cosmos hold for us in the future? Perhaps we will discover that we are connected to the universe in ways we cannot yet comprehend. The search for these mysteries not only brings us closer to knowledge, but also unites us as a species, sharing the same curiosity about what lies beyond our small planet. So, as you embark on this journey through the mysteries of the universe, remember that every question that arises is an open door to new possibilities. What new wonders will we discover together in the coming hours? The universe awaits us with open arms, full of secrets eager to be revealed. The adventure is just beginning. What is the secret behind dark hydrogen? This intriguing concept has captured the imagination of scientists and universe enthusiasts alike. In a cosmos where visible matter constitutes only a small fraction of what exists, dark hydrogen presents itself as a possible key to understanding the matter we cannot see, that which seems to be hidden in the shadows of space. Imagine that dark hydrogen is a hypothetical form of this essential element, which could play a crucial role in the composition of dark matter. But how is it possible that something we cannot observe has such a significant impact on the universe? Dark matter, believed to make up around 95% of the cosmos, is a true enigma. Its presence manifests through gravity, but so far it has eluded our attempts at direct detection. Some researchers suggest that dark hydrogen could be responsible for the gravitational attraction we feel in space. What if this type of hydrogen formed under extreme conditions such as those found in the hearts of stars or in the early stages of the universe? This idea is not only fascinating, but also opens the door to a multitude of questions. What other forms of hydrogen might exist that we have yet to discover? How does this affect our understanding of the evolution of galaxies and the cosmos as a whole? The search for dark hydrogen also leads us to explore the concept of invisible matter. Throughout history, scientists have attempted to unravel the mysteries of this elusive material, and each new discovery seems to raise more questions. If dark hydrogen exists, what does that mean for the nature of gravity and the structure of the universe? The idea that there is a substance that does not interact with light but has a tangible impact on visible matter is nothing short of astonishing. In the realm of theoretical physics, various theories have been proposed to explain the nature of dark hydrogen. One of the most intriguing is the idea that it could be composed of particles that we have not yet identified. But how could we detect something that does not emit light or energy? This is where the creativity of scientists comes into play. Using telescopes and experiments in particle accelerators, new ways are being designed to search for clues about its existence. Imagine that in the future we manage to detect dark hydrogen. What implications would that have for our understanding of the universe? It could revolutionize our view of cosmology, challenging existing theories and leading us to rethink what we know about the formation of stars and galaxies. This search is not only scientific but also philosophical, as it questions our own position in the vast cosmos. Dark hydrogen also invites us to reflect on matter in its purest form. What does matter really mean? As we explore this concept, we find that science often lies at the intersection of the known and the unknown. The possibility that there are forms of matter we cannot see or measure is a reminder of how limited our understanding is. However, life on Earth has evolved in a cosmos full of mysteries, and speaking of mysteries, dark hydrogen could be the key to understanding phenomena such as the accelerated expansion of the universe. But how do these ideas relate to what we observe in the sky? Every new clue we find about dark hydrogen could be a step towards solving deeper enigmas. As we continue to investigate, it is vital to remember that science is a journey. Each discovery leads to new questions and challenges. Dark hydrogen is just a chapter in the story of our attempt to understand the universe. What other secrets await revelation? With each technological advance and each new telescope, we come a little closer to unraveling the complexity of the cosmos. In conclusion, the mystery of dark hydrogen is not only fascinating from a scientific perspective, but also invites us to consider our own existence in the vast universe. The quest for answers about this enigma could change our understanding of matter, gravity, and the structure of the cosmos. So the next time you look up at the starry sky, remember that among those distant lights, there could exist a form of hydrogen that challenges our current understanding. Are you ready to continue exploring the mysteries of the universe? The adventure is just beginning. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. In the vast oceans of space, there is a place where life could hide in the most unexpected corners. Let's talk about habitable moons, those giant satellites that orbit distant planets and at first glance might seem desolate, but what if I told you that beneath their icy surface there could exist oceans of liquid water where life as we know it could flourish? One of the protagonists in this search is Europa, one of Jupiter's moons. With a surface covered in ice, Europa has intrigued scientists for decades. But what lies beneath that ice? Research suggests that there could be a vast ocean of salty water, making it an ideal place for life. Could we really find some form of organism within? Imagine creatures that have evolved in darkness, far from sunlight, in an environment that could be so different from ours, and Europa is not the only candidate. Titan, Saturn's largest moon, also has its own mystery. With its dense atmosphere and lakes of methane on its surface, Titan appears to be a completely alien world. Could life on Titan be radically different from what we know here on Earth? Scientists are beginning to explore the possibility that, although methane is not water, there may be life forms that adapt to those extreme environments. But how do we know if these places are truly habitable? The key may lie in chemistry. On Earth, life is based on water, but on other worlds, there could be other solvents that allow vital chemical reactions. What if life on Europa or Titan used methane as a basis? It's an idea that challenges our current understanding, but science is always willing to explore the unknown. As telescopes become more powerful and space missions are designed to explore these worlds, more questions arise every day. How can we send probes to these distant places? What tools do we need to study their composition and search for signs of life? Plans for future missions to Europa are exciting. There is talk of sending ships to drill through the ice and analyze the water for microorganisms. But the search doesn't stop at Europa and Titan. Other moons like Enceladus have also shown signs of hydrothermal activity, suggesting they could harbor conditions favorable for life. Why not explore beyond the known? The universe is full of moons orbiting distant planets, many of which have unique characteristics that could surprise us. One of the most intriguing questions is, how did these habitable moons form? Are they mere remnants from the formation of their planet, or did they have a more complex origin? The answer to this question could give us clues about the formation of other solar systems and the possibility of life in other corners of the cosmos. In this quest to find life on moons, we must also consider the possibility that if we find life, it could be very different from our own. What would it look like? Would it be microscopic or perhaps something larger? The biology of other worlds could surprise us in ways we haven't even imagined. As we look to the future, we can't help but wonder, what if we find life on these moons? The implications of such a discovery would be monumental. It would force us to rethink our position in the universe and question what we know about life itself. With each new mission and each discovery, we get a little closer to unveiling these mysteries. Human curiosity is insatiable, and the search for answers about habitable moons reflects our innate desire to explore. Meanwhile, the universe continues to keep its secrets. The moons of other planets are just a part of a larger puzzle. Each new moon we discover is an opportunity to expand our understanding of the cosmos. What other surprises await us in the far reaches of space? So the next time you look up at the starry sky, remember that the moons orbiting far from our view could be bearers of life. The search for the unknown continues, and with each question we answer, new mysteries arise that push us to keep exploring. In this vast universe, there are no limits to curiosity and the desire to discover what it truly means to be alive. What makes a hypergiant star so special? These colossal gas spheres, which can be up to 1,000 times larger than our own sun, are not only impressive because of their size. Their existence raises profound questions about the formation and evolution of stars. How can they reach such extreme dimensions without collapsing under their own weight? The answer lies in the delicate balance between gravity and the internal pressure generated by nuclear fusion in their cores. But what happens when that balance is disrupted? Hypergiant stars like the famous Scuti are found in the final stages of their lives. As they consume their nuclear fuel, their structure becomes unstable. But what causes some of them to become Type II supernovae, while others simply fade away? This is a puzzle that still confounds astronomers. The explosion of a supernova is a cosmic spectacle, but is there an intermediate path where a star can vanish without a trace? The light emitted by these stars can be so intense that it becomes visible at incredible distances. However, their lifespan is relatively short in astronomical terms. How is it possible for something so bright and massive to live only a few million years? In comparison, our Sun has existed for over 4 billion years. Hypergiant stars seem to be in a race against time, and their rapid energy consumption poses a fascinating dilemma. Is the speed at which they live their lives linked to their size? Astronomers have identified several of these stars in our galaxy and beyond, but how do we find them in the vast cosmic ocean? They are often detected through their spectral characteristics, which reveal their chemical composition. Each star tells a story through its light, but what secrets lie behind the unusual compositions of some hypergiants? Could these stars be creating elements heavier than carbon which will then spread throughout the universe? One of the most intriguing features of hypergiant stars is their ability to form stellar winds. These winds are massive flows of gas that can reach speeds of thousands of kilometers per hour. But how do these winds influence the formation of new stars and the dynamics of their galaxies? While some stars disperse their material into space, others seem to keep it trapped in their dense atmospheres. Is it possible that some hypergiants act as true factories for new elements in the universe? Additionally, hypergiant stars often cluster in star clusters. What does this tell us about the history of star formation in our galaxy? These clusters can contain hundreds of stars of different sizes and ages. each with its own life story. The interaction between these stars can lead to fascinating phenomena such as mass transfer between them. How does this affect their evolution and their ultimate fate? The life cycle of a hypergiant star is an impressive reminder of the ephemeral nature of stars. While some may end their lives in a spectacular explosion, others may fade away silently. But what happens to the matter left behind by these stars at the end of their lives? Does it become part of a new generation of stars and planets? Or does it disperse into the void of space? The answer to this question is crucial for understanding how the universe is formed as we know it. In the search for answers, astronomers have developed theoretical models to predict the behavior of these giant stars. However, reality often challenges these theories. What surprises does the universe hold in store for our understanding of hypergiant stars? Each new discovery seems to open the door to more questions. Research continues, and each observation provides us with a deeper insight into these colossi. As we explore the life and death of hypergiant stars, we are led to reflect on our own place in the cosmos. What can we learn from these majestic entities? Their existence reminds us that the universe is in constant change and evolution, and that each star, no matter how big or small, has a role to play in the vast cosmic web. The fascination with hypergiant stars lies not only in their size or brightness, but in the stories they tell about birth and death in the universe. How do their lives intertwine with those of other stars and with the formation of galaxies? The quest for answers to these questions motivates us to look up and explore beyond what we know. So are we ready to unravel the secrets of hypergiant stars? With each advance in technology and each new telescope launched into space, we get a little closer to understanding these wonders of the cosmos. The adventure of exploring the universe never ends, and there are always more mysteries waiting to be discovered. What revelations will the future bring us about these colossal stars? The answer is undoubtedly among the stars themselves. Have you ever stopped to think about how tiny floating particles can have such a significant impact on the origin of life? In the vast ocean of space, there exists a mysterious component known as cosmic dust. This dust, often overlooked, is much more than mere dirt in the universe. It is a silent witness to cosmic history. But what exactly is cosmic dust, and why is it so important to us? Cosmic dust is a mixture of tiny particles found in space, composed of elements like carbon, silicon, and metals. But where does it come from? The answer lies in the remnants of stars that have reached the end of their life. When a star explodes in a supernova, it releases a massive amount of material into space, which eventually becomes this dust. So could it be that our own solar system formed from these cosmic particles? Think about this. Cosmic dust has been traveling through space for billions of years. During that time, it has witnessed the creation of stars, planets, and possibly even life itself. On Earth, it is believed that cosmic dust has contributed the necessary elements for the formation of organic molecules. But how can something so small play such a crucial role in the creation of life? Some scientists suggest that cosmic dust could have been the catalyst that helped form the first organic compounds on our planet. These compounds, in turn, could have given rise to the first forms of life. Imagine, every time you look up at the sky, you could be observing the same materials that gave rise to life on Earth. Isn't it fascinating to think that we are made of stardust? Moreover, cosmic dust is not only vital for life on Earth. In the universe, it acts as an essential ingredient in the formation of new stars and planetary systems. When clouds of gas and dust collapse under their own gravity, cosmic dust plays a key role in the creation of new celestial bodies. But what happens when dust accumulates excessively? Some theories suggest that cosmic dust may influence the formation of black holes. When enough matter accumulates, gravity intensifies, and the dust could be the first step toward creating one of the most mysterious objects in the universe. How is it possible that something as fragile as dust can become one of the most powerful phenomena in the cosmos? However, not all cosmic dust is the same. There are different types, and their composition can vary greatly. Some particles may be composed of heavy metals, while others may be entirely organic. This diversity may provide clues about the history of the universe and how different stellar systems formed. What secrets does cosmic dust hold about the universe's past? In the context of our own galaxy, the Milky Way, cosmic dust plays a fundamental role in the formation of new stars. Astronomers have observed that regions with a high concentration of dust are also where new stars are forming. Could it be that dust is the true architect of the universe, shaping not only our environment but also that of other systems? As dust accumulates, it can also influence how we perceive the universe. Dust clouds can obscure the light from distant stars, making some of them invisible to our telescopes. What cosmic wonders might be hidden behind these mysterious clouds? The answer to this question could change our understanding of the cosmos. Some studies have found that cosmic dust may also contain complex molecules that are precursors to life. Could it be that life, as we know it, is not just a phenomenon of Earth, but that its origin is scattered throughout the universe in the form of dust? If so, we might be surrounded by the same building blocks that gave life to other worlds. As scientists continue to investigate the role of cosmic dust, new surprises keep emerging. Each particle can be a time capsule containing information about the history of the universe. But what else could the study of this cosmic dust reveal to us in the future? Perhaps, within the dust of the stars, lies the key to unlocking other mysteries of the universe. In summary, cosmic dust is more than just a simple residue in space. It is an essential component that connects the past, present and future of the cosmos. From the creation of stars to the possible formation of life, its influence is undeniable. What other secrets will cosmic dust continue to reveal as our technology and understanding of the universe advance? So the next time you look up at the starry sky, remember that, at its core, you are looking at the same materials that have traveled for eons, shaping everything we know. Cosmic dust is not only part of the universe's history, it is also part of our own story. What revelations await us in the future as we continue to explore this fascinating component of the cosmos? What is happening with those planets that seem to be evaporating? In the vast ocean of space, some worlds are doing something surprising. They are disappearing. But how is it possible for a planet to fade away? The answer lies in the intense radiation from their stars, which acts like a powerful laser, wearing down the atmosphere of these planets and taking part of their essence with it. Imagine a planet that, instead of quietly spinning in its orbit, is caught in a dangerous dance with its star. This is what happens with the so-called evaporated planets. They are so close to their sun that the amount of energy they receive is overwhelming, enough to heat their atmosphere to extreme temperatures. What effect does this have? The atmosphere, which at first might have been rich in gases and compounds, turns into vapor and escapes into space. Soon, what was once a vibrant world becomes a blurry memory. Have you ever wondered how these unusual planets are discovered? Astronomers use telescopes and detection techniques that allow them to observe changes in the light from stars. When a planet passes in front of its star, it blocks some of the light, creating a small but detectable dip in the stellar brightness. But in the case of evaporated planets, the light reveals much more. As the atmosphere dissipates, scientists can measure the amount of vapor escaping and thus infer what is happening on the planet. A fascinating example of this phenomenon is a planet called WASP 121b. This world is so extreme that its temperature can exceed 1,500 degrees Celsius. In such hot conditions, it is almost impossible for matter to maintain its original form. Scientists have discovered that, instead of a dense atmosphere, WASP 121b seems to have a halo of vapor that is constantly escaping into space. But what about the components of its atmosphere? Some of them, like sodium and potassium, have been detected in the light it emits, suggesting that the planet is indeed losing part of its essence. But it is not just the elements that are evaporating. There is also a struggle between gravity and radiation pressure. The star that illuminates these planets not only heats them, but its powerful gravity acts like a magnet that traps what remains of their atmosphere. However, in some cases, this force is not enough to contain the escaping vapor. Thus, with each passing second, these planets shed their atmosphere, slowly becoming desolate worlds. The mystery does not end here. What other factors could be influencing this evaporation phenomenon? Astronomers are beginning to investigate whether the chemical composition of a planet plays a fundamental role in its ability to withstand this atmospheric loss. Planets made mostly of light elements, like hydrogen, could be more vulnerable to this intense radiation, while others with heavier atmospheres might have a better chance of surviving. Moreover, the distance of a planet from its star is not the only variable. The tilt of its orbit, the activity of the star itself, and other factors also influence how a planet can resist or succumb to evaporation. This creates an intriguing puzzle that scientists continue to try to solve. There are even theories suggesting that some of these evaporated planets could be the remnants of worlds that were once more lush. Perhaps in a distant time, these planets had oceans, clouds, and dense air. But the voracious radiation from their star has transformed them into what they are today. So, could they have harbored life at some point in their existence? The answer remains a mystery. The exploration of these evaporated worlds is not only fascinating, but also offers us clues about the formation and evolution of planets in our own solar system. By understanding how stellar radiation can influence a planet's life, we can begin to apply that knowledge to our Earth and other distant worlds in the search for life. However, the sense of loss is palpable. Each evaporating planet is a reminder of how fleeting the universe can be. Although space is immense, nature has its ways of making even the largest worlds fade away. This fragility invites us to reflect on our own existence and the role we play in this vast cosmos. As we continue to explore and discover new planets, the search for answers leads us to understand not only what these worlds are, but also what they could have become. Science becomes a story of transformation, where each discovery opens new questions and brings us one step closer to unraveling the secrets of the universe. So, as we gaze at the starry sky, let us remember that there are worlds struggling to survive. Worlds that tell us stories of loss and change. Every star that shines in the night could be the beacon of a planet that, although distant, invites us to keep exploring and questioning the mysteries that the universe has in store for us. What happens when a planet is larger than Earth but not as immense as Neptune? This intriguing phenomenon is known as a super-Earth, and its existence has captured the imagination of scientists and astronomers alike. But what exactly is a super-Earth, and why does its formation remain a mystery? Join me on this fascinating journey through the cosmos. In the vast universe, thousands of exoplanets have been discovered, many of which fall into the category of super-Earths. Most of them are larger than our home, but not large enough to be considered gas giants. This raises a series of questions. How do they form? Why are they so common compared to other types of planets? To understand this, we must first explore what distinguishes them. Super-Earths can have rocky surfaces, oceans of water, or even dense atmospheres. However, there is a great enigma surrounding their composition and structure. Some scientists suggest that they might be made of materials we have not found in our solar system. What if the super-Earth closest to us has a type of rock or mineral that challenges our current understanding? Imagine the possibility of discovering a new type of matter on one of those worlds. One of the most intriguing questions is how these super-Earths form. The most popular theory suggests that they start as rocky cores, which then attract gas from their surroundings. But why do some super-Earths end up being larger than others? Is it a matter of time? Or perhaps the amount of gas available when they form? Each new discovery adds more layers to this puzzle. Moreover, the study of super-Earths also leads us to question the habitability of these planets. They could harbor life as we know it, or perhaps a completely different form of life. What conditions would be necessary for life to thrive on such a different world? Could we find oceans of liquid water or oxygen-rich atmospheres on any of these super-Earths? The search for answers to these questions drives us to explore beyond the limits of our solar system. Another fascinating aspect is the diversity of super-Earths that we have found. Some are warm and rocky, while others seem to be colder and covered in ice. What factors influence these differences? The distance from their stars, the composition of their atmosphere, and other elements play a crucial role. This leads us to wonder, is there a super-Earth that is a true twin of Earth with similar conditions that allow for life? Some super-Earths also exhibit unusual characteristics, such as dense atmospheres that could be hostile to any form of life we know. What kind of geological processes could be occurring on these planets? Volcanic activity, plate tectonics, or even extreme atmospheric phenomena could shape these worlds in ways we are just beginning to understand. An additional enigma lies in the number of super-Earths that have been discovered compared to other types of planets. Why do they seem to be so common compared to Earth-sized planets? Could it be that super-Earths are an intermediate step in the evolution of planets? Perhaps in the future we will witness how some of these super-Earths become gas giants. Advances in technology have allowed us to observe beyond our solar system. Thanks to increasingly powerful telescopes, we have been able to identify super-Earths in distant stellar systems, but how many more do we have yet to discover? Each new finding could change our understanding of the universe. Are we on the verge of finding a new world that challenges all our theories? One aspect we cannot ignore is the relevance of super-Earths in the search for extraterrestrial life. Science has begun to seriously consider the possibility that some of these planets may harbor forms of life. What kind of beings could inhabit such different worlds? Each discovery forces us to rethink what we know about life and its formation. With each super-Earth we identify, new theories and questions arise. Will some of these super-Earths become destinations for future space missions? Human curiosity knows no bounds, and exploring these worlds could provide answers to some of the deepest questions we have about our place in the universe. The search for super-Earths also allows us to reflect on the fragility of our own planet. We know Earth and its unique conditions, but as we explore other worlds, we realize how special it is and what we could lose. Could these super-Earths teach us something about conservation and the future of our home? Each new discovery about super-Earths brings us one step closer to solving the enigma of their existence. Science advances, and while many questions remain unanswered, exploration continues. What surprises does the future hold? Only time will tell. What is certain is that the search for super-Earths will take us to places we never imagined and help us better understand the vast universe in which we live. What do hot giant planets and a lit oven have in common? Both are the result of extreme heat, but in the case of these planets, the situation is even more puzzling. Astronomers have discovered worlds that orbit so close to their stars that the temperature on their surface can reach unimaginable levels. How is it possible for planets to exist under such conditions and not turn into a sea of lava? The first question that arises is, what is a hot giant planet? These are worlds that are significantly larger than Earth, but are so close to their star that their atmosphere heats up to extremely high temperatures. Imagine a gas giant that, instead of being at a safe distance, has come so close to its sun that its temperature exceeds 1000 degrees Celsius. It sounds incredible, but it is a reality that challenges our previous notions about planet formation. Some of these planets are so hot that scientists wonder, what kind of atmosphere can they have? In theory, it should be an inhospitable place where any molecule trying to form a gas is torn apart by the intense heat. However, telescopes have detected elements like sodium and potassium in their atmospheres, leading us to ask, how is it possible for those elements to survive in such an extreme environment? Current models of planet formation fail to explain why these planets exist. One would expect something so hot to evaporate or, at the very least, not remain in its gaseous state. But this is where science becomes a guessing game. The question is there something in the formation process of these planets that we do not understand? Could it be that they form from an unknown interaction between gravity and the heat of their star? One theory suggests that these planets may have started in a more distant orbit and due to some cosmic event were dragged toward their star. But what kind of event could cause such a thing? Some scientists think they could be the result of interactions with other planets or even with nearby stars. This opens up a new range of questions. How many planets have changed orbits throughout their lives? And how many stories of cosmic chaos lie behind each of them? By observing these worlds, astronomers have noticed that some of them have atmospheres that expand and contract. This generates a phenomenon known as extreme weather, where temperatures can fluctuate drastically over a short period of time. How can a planet withstand such changes? The answers remain a mystery. But scientists are increasingly intrigued by the complexity of these systems. Not only is temperature an enigma, but also the chemical composition of these planets. Evidence has been found that some of them have clouds of liquid metal. What kind of conditions must exist for clouds of this type to form? This question adds an additional layer of wonder as it leads us to imagine a world where rain is not water but metal. The discovery of hot giant planets has led scientists to rethink everything they thought they knew about planet formation. Are these planets an isolated case or part of a broader phenomenon? As new worlds are discovered, the diversity of the universe becomes more evident, prompting us to question our most fundamental theories about how planets are created and evolve. The search for answers is far from over. Space observatories like the James Webb Space Telescope are designed to study these mysteries in depth. With its ability to observe in different wavelengths, scientists hope to unravel the secrets of these planets. What other mysteries might be revealed in their atmospheres? What will they tell us about the formation of other planetary systems? As we delve into the study of these worlds, it is important to remember that each discovery raises new questions. Each hot giant planet invites us to explore not only its nature but also the history of the cosmos. What do they teach us about the laws that govern the universe? And how might they change our understanding of what it means to be a planet? As data accumulates, scientists realize that the universe is a much stranger place than they thought. The planets that orbit so close to their stars are a constant reminder that what we think we know can change in an instant. Each new finding is like a piece of a puzzle that never seems to be completed. The possibilities are endless, and as technology advances, so does our ability to explore these mysteries. Who knows what other secrets await discovery in the depths of space? The search never ends, and each answer seems to open the door to more questions. In an ever-expanding universe, hot giant planets teach us that sometimes the strangest and most mysterious things can be right next to what we think we know. As we continue to investigate, we get a little closer to understanding not only these worlds but also our place in the vast cosmos. Human curiosity is insatiable, and with each discovery a new spark of wonder is ignited, driving us to keep exploring. What other wonders will the universe reveal to us in the future? What lies hidden in the depths of the cosmos? Among the wonders of the universe, we find a mystery that, although subtle and almost imperceptible, has the potential to change our understanding of the formation and evolution of galaxies. We are talking about starless galaxies, celestial bodies that seem to defy the norms of astrophysics. How can enormous structures exist without the light we normally associate with stellar life? The first question that arises is, what exactly are these starless galaxies? They are vast formations that lack the bright light emitted by stars. Instead of dazzling us with their splendor, these galaxies seem to be made of dark matter or cold gas, making them almost invisible to our eyes. However, their existence has been confirmed through indirect observations. So, how can we be sure they are there? The answer lies in the way they interact with their environment. Despite their almost ghostly nature, these galaxies exert a gravitational influence on nearby galaxies. Astronomers have been able to detect them by observing how neighboring galaxies move. Isn't it amazing to think that something so ethereal can have a tangible impact on the cosmos? Let's imagine that these galaxies are like shadows in a lit room. Although we cannot see them, their presence is felt. But why are there galaxies that seem not to have formed stars? One theory suggests that these structures could be remnants from a very early period in the history of the universe, when matter was in the process of formation and there was not yet enough density for stars to begin shining. Could these galaxies be like time capsules that offer us clues about the cosmic past? The questions do not end there. If these galaxies are so ancient, what do they tell us about the evolution of the universe? Their existence poses a challenge to our current theories about galaxy formation. For a long time, we have assumed that star formation is a fundamental step in the creation of galaxies. But here we have an example that seems to contradict this idea. Could it be that starless galaxies are a normal stage in the evolution of galaxies, a phase we simply had not considered? Moreover, there is a fascinating aspect related to dark matter. It has been suggested that these galaxies could be largely composed of this mysterious matter that does not emit light or energy. This leads us to a dilemma. Could these galaxies be the home of dark matter in a form we do not yet understand? Dark matter is one of the great mysteries of the universe, and these galaxies could be the key to understanding its role in the structure of the cosmos. Some researchers have begun to speculate that these galaxies could be the result of galactic mergers. When two galaxies combine, the energy released could trigger the formation of new stars in one of them, while the other might lose its ability to form new stars. Could these starless galaxies be the echo of past cosmic events that still resonate in space? As telescopes advance in their ability to observe the universe, we find ourselves in a unique position to discover more about these hidden galaxies. Modern technologies have allowed scientists to delve into regions of the universe that were previously unreachable. What else will these new findings reveal about the nature of starless galaxies? Another intriguing question is, could these galaxies be home to completely different forms of life? Although most current theories about life focus on stellar systems, the existence of these galaxies could open new possibilities. Could there be organisms that do not depend on starlight to thrive? This perspective invites us to rethink what we know about life in the universe. As we continue to explore, it is also essential to consider the impact that these galaxies could have on the formation of new cosmic structures. The gravitational dynamics they exert could influence the creation of new bright galaxies. Could they be laying the groundwork for the next generation of stars and planets? The history of the universe could be full of surprises, and these starless galaxies might be unexpected protagonists in that narrative. In conclusion, starless galaxies are a reminder that there is still much to discover in the vast cosmos. They invite us to question our assumptions and expand our understanding of the matter and energy that make up the universe. Each new revelation about these mysteries brings us a little closer to unraveling the secrets hidden in the shadows of space. The search for answers is endless, and in every corner of the universe there are enigmas waiting to be solved. What other secrets will the cosmos reveal to us in the future? Only time and human curiosity can answer that question. Have you ever stopped to think about the rings of planets? These majestic celestial adornments have fascinated astronomers and curious minds alike. But what happens when we delve into the mystery of the rings of distant planets? Are they really as simple as those of Saturn, or do they hide secrets that we have yet to uncover? Saturn's rings are the most famous, but there is an entire universe filled with exoplanets that feature even more complex ring structures. Some of these exoplanets are thousands of light years away in solar systems that we are just beginning to understand. How is it possible that these distant worlds have rings, and what can they tell us about the formation of planetary systems? Astronomers have detected rings on planets that orbit so close to their stars that the conditions are extremely hostile. Intense radiation and extreme heat could disintegrate any material, yet surprisingly, there are the rings, defying all expectations. What keeps them together? What mysteries lie within these bright and often irregular structures? One of the most intriguing planets we have found is a gas giant that, like Jupiter, has rings, but these are much larger and more complex. Imagine a ring system that extends for millions of kilometers, made of ice and dust particles that reflect the light of its star. How did they form? And why are they so different from those we know in our own solar system? The dynamics of these rings are fascinating. In some cases, gravitational interactions with nearby moons have been observed to create ring structures that resemble waves or patterns. But what happens when those moons are destroyed? Could it be that these rings are the result of the disintegration of celestial bodies? The story of the rings could be a chronicle of chaos and beauty in the cosmos. Moreover, the composition of distant rings may offer clues about the history of their solar system. Some rings are made up of materials we did not expect to find, suggesting that these planets have undergone a very different evolution than ours. What kind of events or conditions could have led to the creation of such unusual rings? In the vast ocean of the universe, the rings of distant planets could also be indicative of the existence of life. Could the material that makes up these rings be the same that, at some point, helped seed life on other worlds? The connection between rings and life is a topic that continues to intrigue scientists. And each discovery opens new doors to speculation. Imagine an exoplanet that, when observed, reveals a ring system with structures that defy logic. Some rings appear to be formed by fragments of asteroids, while others are surprisingly homogeneous. What cosmic forces are at play here? Could these planets be in a gravitational dance with other stars or planetary systems that we have yet to observe? Current technology allows us to see beyond the borders of our solar system, revealing worlds that could only exist in our imagination before. Each time a telescope captures the light of an exoplanet, a window opens to a new mystery. What more can we learn from these rings that spin in the darkness of space? Rings are not just a matter of aesthetics, they are windows into the history of a planet and its solar system. Their study could provide us with information about planet formation and the evolution of stars. Each ring is a chapter in the cosmic book that narrates the events that shaped that particular system. In the end, the quest for answers about the rings of distant planets is a journey that never ends. Each answer leads us to new questions, and each discovery reminds us how little we know about the cosmos. The next time you look up at the sky, think about those mysterious rings that orbit distant worlds, and consider the role they play in the vast history of the universe. So what secrets do the rings of distant planets hold? Are they truly simple adornments, or are they vital clues that will help us understand life and the universe as a whole? The exploration of the cosmos continues, and we are witnesses to a journey filled with enigmas and astonishing discoveries. Are you ready to keep exploring the mysteries that the universe offers us? What if I told you that there are worlds in the universe that are composed almost entirely of diamond? Imagine a planet where carbon has crystallized in such a way that its surface shines like a jewel in the darkness of space. This is the enigma of diamond planets, a mystery that fascinates astronomers and the curious alike. First of all, how is it possible for a planet to be made of diamond? The answer lies in the extreme conditions of temperature and pressure. On certain giant planets, like those orbiting very massive stars, carbon, which is normally found in gas form or in simpler structures, can transform into crystalline structures. This occurs due to the immense gravity and intense pressure within them. Thus, these worlds become gigantic floating diamonds in the vast ocean of the cosmos. But where can we find these planets? So far, scientists have identified several exoplanets that might have these characteristics. For example, a planet called 55 Cancri e, located about 40 light-years away in the constellation Cancer, has captured researchers' attention. This exoplanet is twice the size of Earth, and its composition is believed to be rich in carbon. Could it be that its surface is covered in sparkling diamond? So far, there is no way to confirm it, but the mere possibility is astonishing. The question that arises is, what implications would such a world have for the search for life? While diamond is a fascinating material, it is not an element that allows for life as we know it. However, diamond planets could offer clues about the formation of other planets and the processes that give rise to life in extreme environments. The conditions on these worlds could be very different from what we know, challenging our ideas about how and where life can arise. Imagining a planet covered in diamonds also leads us to reflect on resources. In a world where carbon is present in the form of diamond, could we find a new type of space mining? If we ever manage to visit these planets, the economic potential could be immense. However, this raises ethical questions about the exploitation of resources on other worlds. Should we do it? Would we truly understand the consequences of our intervention in those extraterrestrial ecosystems? As telescopes become more powerful and technology advances, more exoplanets are being discovered that surprise us with their peculiarities. Some of these worlds have conditions that challenge our current understanding of planetary formation. Diamond planets are just one side of the coin. What other mysteries lie hidden in the corners of the universe? The study of these exoplanets also helps us understand how planetary systems form and evolve. The composition of a planet can offer clues about the history of its stellar system by analyzing the light it emits or reflects. Scientists can deduce the presence of different elements and compounds. This not only gives us information about the planet itself, but also about its parent star and its environment. The search for diamond planets also invites us to question our own notions of beauty and value. On Earth, diamonds are considered objects of desire, symbols of wealth and luxury. But in the context of the universe, what does it really mean to have a planet made of diamond? Is it a treasure or simply another natural phenomenon? These questions lead us to rethink our priorities and our relationship with the cosmos. Moreover, the existence of these worlds reminds us how little we know about the vastness of the universe. Each new discovery raises more questions than answers. As we explore beyond our solar system, the diversity of planets and their unique characteristics show us that the universe is a place full of surprises. What other secrets could be revealed if we continue to investigate? Science is advancing by leaps and bounds, and with it, our tools for exploring the universe. Each new space mission and each new telescope launched into space brings us a little closer to unveiling the mysteries that still endure. In summary, diamond planets are just one of the many wonders that the universe has to offer. Although their existence may seem straight out of a science fiction story, the reality is that they are out there, waiting to be discovered and studied. Each advance in astronomy allows us to dream of what might lie beyond our home on Earth. The exploration of these worlds invites us to keep dreaming and questioning, to not settle for what we know, and to always seek more. Each answer leads us to new questions, and that is how human curiosity continues to drive our quest for knowledge. What other mysteries of the universe await us just around the corner? The adventure is just beginning. What happens to the stars that simply stop shining? In the vast cosmos, there are phenomena that challenge our understanding. Imagine a star that has illuminated the sky for millions of years and suddenly, overnight, it ceases to emit light. How is it possible that a star, which in theory should explode at the end of its life in a spectacular supernova, simply goes out without warning? Stars are, in essence, enormous nuclear factories. In their core, they fuse hydrogen into helium, releasing an incredible amount of energy that translates into light and heat. But what happens when this process is interrupted? Stars are not eternal entities. They have life cycles that depend on their mass and composition. Some, the most massive, eventually collapse and explode, while others, lighter ones, may have a very different fate. But what about those that seem to disappear without causing an explosion? This phenomenon has puzzled astronomers for years. Stars have been detected that simply go out, and while there are theories about what might be happening, there are still no definitive answers. Could they be turning into white dwarfs, or are there darker processes at play that we do not yet understand? Some of these stars have been observed in nearby galaxies. Often, scientists wonder if they could be part of a larger process, perhaps related to dark matter or dark energy, two of the greatest enigmas in astrophysics. The idea that something as massive as a star could disappear from our view without a trace is unsettling, but also fascinating. An interesting aspect is the role that gravity plays. Could it be that when approaching another massive object, a star is pulled into a black hole, disappearing in an instant? This scenario is one of many that researchers are exploring. However, the lack of light and radiation makes these stars difficult to detect, further complicating our understanding. The search for answers leads us to consider how these stars behave at different stages of their life. For example, some may enter a state of instability where their outer layers become irregular and begin to lose mass. This process could cause their light to gradually diminish, leading to a subtle blackout instead of an explosive end. An area of study that has gained relevance is the relationship between these stars and their environment. How do interactions with other stars and galactic structures influence their evolution? Perhaps the key to understanding these disappearances lies in the dynamics of galaxies, where stars are not isolated entities but part of an intricate cosmic fabric. And when we talk about disappearing stars, we cannot ignore the impact this has on our understanding of the universe as a whole. Each star that goes out is a reminder of how fleeting life can be in the cosmos. What lessons can we learn from these phenomena? Are we facing a signal that the universe has more surprises in store for us? Astronomers continue to observe and gather data, trying to unravel the mysteries behind these enigmatic stars. Modern technology allows us to study the cosmos in ways that were once unimaginable. With more advanced telescopes and data analysis techniques, we are closer than ever to discovering what is really happening. Some scientists suggest that these stars could be the result of a new class of stellar phenomena that we have not yet categorized. If so, what implications would this have for our understanding of stellar evolution? Could it be that in the near future we will be able to observe events that we currently consider impossible? Ultimately, each star that disappears is a reminder that the universe is a place full of surprises and mysteries. It pushes us to question what we know and to keep seeking answers. Human curiosity has led us to explore, to ask and to discover, and it is likely that each new answer will generate even more questions. So the next time you look up at the sky and see a star shining, remember that behind that light lies a complex and mysterious life cycle. Some of those stars may be at the peak of their existence, while others may be in their twilight, preparing to disappear into the vastness of the cosmos. What secrets do they hold? How many more have been lost in the mists of time, leaving only echoes of their existence? The search for answers is an endless journey, and each disappearing star invites us to keep exploring. In this vast universe, there will always be more mysteries to uncover, and each solved enigma will only lead to new questions and new wonders. Such is the cosmos, a place where the unknown is the norm and where human curiosity guides us toward the light of truth. In the vast universe, every star, every galaxy seems to tell a story, but there is a mystery that has left astronomers perplexed: the enigma of galactic velocity. Why do some galaxies appear to be moving away from us at speeds that challenge our understanding of the cosmos? This intriguing phenomenon leads us to wonder, what forces are at play in the immensity of space? When we observe the night sky, what we are seeing is only a fraction of the universe. However, by studying the light from distant galaxies, scientists have noticed a puzzling pattern. Some galaxies are moving away from us at astonishing speeds, much faster than current models of the universe's expansion predict. Why is this happening? Are these galaxies in some kind of cosmic race? The most common theory about the expansion of the universe is the Big Bang model, which suggests that the universe began as an extremely dense and hot point and has been expanding ever since. However, the speed at which some galaxies are separating seems to indicate that something else is at work. Could it be that unknown forces are driving these galaxies to such extreme velocities? Astronomers have measured these speeds using the Doppler effect. This phenomenon, which we also observe in sounds, manifests in the light emitted by galaxies. When a galaxy moves away from us, the light it emits shifts towards the red, a phenomenon known as redshift. But what about galaxies that are receding at speeds that seem to defy the logic of physics? Imagine these galaxies as cars on a highway. Some are going at normal speeds, while others seem to be accelerating out of control. This irregular behavior has led scientists to investigate possible explanations. One of the most intriguing theories is the existence of an unknown form of energy, referred to as dark energy. This energy could be pushing galaxies to separate more rapidly. But what is dark energy really, and how might it influence galactic movement? In addition to dark energy, another fascinating question arises. Could there be gravitational interactions between galaxies that explain these unusual speeds? As the universe expands, galaxies are not distributed uniformly. Some cluster together while others appear isolated. These interactions could be affecting the movement of galaxies and causing some to recede faster than others. But how can we test these theories? Modern telescopes have allowed astronomers to observe beyond nearby galaxies, exploring the universe for answers. However, each discovery raises more questions. For example, if there are galaxies moving away at extreme speeds, what implications does this have for the future structure of the universe? Are we witnessing a universe that expands endlessly, or is there a point at which this expansion could reverse? As scientists continue their search for answers, the mystery of galactic velocity reminds us of how little we truly know about the cosmos. Each galaxy we observe is not just a distant place, but a puzzle that challenges our understanding of time and space. As technology advances, so does our ability to unravel these enigmas, but there is still much to discover. One of the most surprising aspects of this phenomenon is that while some galaxies seem to be moving away rapidly, others may be on their way toward us. What does this mean for the structure of the universe? The dance of galaxies is complex and often unpredictable. Perhaps in the not-so-distant future, some of these galaxies that are currently receding will become companions to our own Milky Way. Galactic velocity also prompts us to reflect on our place in the universe. If galaxies are moving away at speeds beyond our comprehension, what does this mean for humanity? Are we truly alone in this vast cosmos? Or are there other forms of life observing the same phenomenon from their own worlds, wondering the same thing? The quest for answers to these mysteries has led us to develop new theories and to question what we thought we knew about the universe. As science advances, so does our curiosity and desire to understand. Each galaxy that moves away at high speed is a reminder that the cosmos is full of surprises and that despite our efforts, much remains unknown. Ultimately, the mystery of galactic velocity is a testament to the vastness and complexity of the universe. Each new question that arises drives us to continue exploring, to keep searching for answers among the stars. Although we may not have all the answers today, human curiosity will never cease to seek, and that is what truly defines us as a species. In the end, each galaxy that recedes is an invitation to keep dreaming, to keep exploring, and to keep our quest for knowledge alive in this vast and enigmatic universe. What if I told you that in the vast universe there are galaxies that seem to have an insatiable appetite? These are the cannibal galaxies, a surprising phenomenon that invites us to question what we know about the formation and evolution of galaxies. How is it possible for one galaxy to consume another? What mysteries lie behind this galactic behavior? To understand this phenomenon, it is important to know that galaxies are not just collections of stars, but dynamic structures that interact with each other in fascinating ways. Gravity plays a fundamental role in these interactions, acting as the force that attracts galaxies to unite or, in some cases, devour each other. So why do some galaxies seem to have a voracious appetite for their companions? Astronomers have observed that these cannibal galaxies are especially common in the centers of galaxy clusters, where the density of galaxies is very high. In these environments, galaxies come so close that their gravitational forces come into play, provoking interactions that can lead to merging. But what exactly happens during this process? When one galaxy approaches another, its stars and gas begin to mix, altering its shape and structure. This cosmic dance can result in a complete merger, giving rise to a new, more massive galaxy. But it is not always that simple. Imagine you are observing two galaxies that seem to dance in space. During this process, not only do their stars mix, but their central black holes may also encounter each other. When this happens, a tremendous release of energy occurs in the form of radiation, making these mergers spectacular events in the universe. However, not all cannibal galaxies manage to merge completely. Some may simply steal stars or gas from their neighbors, a process known as galactic cannibalism. But what does this imply for the galaxies that are victims of this appetite? Galaxies that suffer cannibalism can be affected in unexpected ways. Their shape may become distorted, their stars may be stripped of their gas, and in some cases, they may even be expelled from their own galactic home. But what about the fate of the cannibal galaxy? In many cases, by devouring other galaxies, they can become even more massive and bright. This raises interesting questions. Is it possible that cannibal galaxies are the result of an evolutionary process that allowed them to grow and become the large structures we observe today? One fascinating aspect of this phenomenon is that it is not limited to galaxies the size of our Milky Way. It has been observed that even smaller galaxies can participate in these cannibalism events. This suggests that galactic cannibalism is not just a phenomenon of large galaxies, but a process that influences the evolution of all types of galaxies. But why do some galaxies seem more prone to this behavior than others? Astronomers have found that cannibal galaxies are often more common in dense environments such as galaxy clusters. In these places, gravity is more intense, making it easier for galaxies to come close enough to interact. However, this raises an intriguing question. How many galaxies have been devoured in the past, and how many more are at risk of being cannibalized in the future? The answer to this question could change our understanding of the universe. By studying cannibal galaxies, scientists can gain clues about the formation and evolution of the cosmos. Each merger of galaxies can release an astonishing amount of energy, which could influence the formation of new stars. But how does this affect the distribution of matter in the universe? The interaction between galaxies can help explain the distribution of dark matter and visible matter, revealing the complex web that forms our universe. As we advance in our exploration of the cosmos, cannibal galaxies remind us that the universe is a place full of drama and tension. These interactions are not only intriguing, but also essential for understanding how the structures we observe today have formed. Each encounter between galaxies is a reminder of how the universe is in constant change, an endless cycle of destruction and creation. As technology advances and telescopes become more powerful, our knowledge of cannibal galaxies will continue to deepen. Perhaps one day we will discover new forms of galactic cannibalism that challenge our current theories. But for now, each new finding offers us a clearer insight into the intricate relationships between galaxies and reminds us that, in the vast universe, there is always more to discover. The next time you look at the starry sky, remember that behind each point of light there may be a story of galactic cannibalism, a reminder that the universe is a place where life and death, creation and destruction are in constant dance. Have you ever wondered what other surprises the cosmos has in store for us? The search for answers continues, and each new discovery brings us closer to understanding the grandeur of the universe we inhabit. Where does iron come from in the universe? This is a question that has intrigued astronomers and scientists for years. In our quest to understand the composition of galaxies, we have found concentrations of iron in places where, according to our theories, they should not exist. How is it possible for significant amounts of this element to accumulate in regions of space where it has not formed naturally? To understand this enigma, it is important to remember that iron is one of the most abundant elements in the universe, but its formation requires specific conditions. Normally, it is generated in the hearts of stars during nuclear fusion processes and is released into space when these stars die, either in supernova explosions or through stellar winds. However, we have detected regions of iron in galaxies where no obvious traces of these explosions are observed. What does this mean for our understanding of the cosmos? One of the theories that have been proposed is that iron could be dragged into these areas by gravitational interactions. Imagine a galaxy that is in constant motion interacting with other galaxies around it. In these complex dynamics, it is possible that iron from a neighboring galaxy is transferred to another, creating unexpected concentrations. But how does this cosmic theft of elements occur? The idea that galaxies are dynamic and constantly changing entities is fascinating. We often think of them as static structures, but the reality is that they are in a continuous cosmic dance. Gravitational forces play a crucial role in this process. When two galaxies come close enough, they can exchange matter, including the iron that may be floating in their surroundings. However, this theory still needs more evidence to be fully validated. Another possibility is that these concentrations of iron come from even more mysterious processes, such as the formation of black holes. Black holes, those enigmatic objects of the universe, can attract and accumulate matter from their surroundings. It has been suggested that in the process of forming supermassive black holes, iron could concentrate in their vicinity. But how does this connect with the galaxies we observe? In some cases, we have found iron in galaxies that appear to be in an early developmental phase. Could it be that these galaxies are forming stars at an accelerated rate, generating iron sooner than expected? Star formation is a complex process, and in some cases it can be more efficient than we think. However, this does not completely resolve the mystery, as we still need to understand how this iron is distributed in the vast intergalactic space. The mystery becomes even more complicated when we observe that some regions of space exhibit an amount of iron that does not match our expectations. Could there be unknown phenomena influencing the creation and distribution of this element? Some scientists suggest that there may be astrophysical processes that we have yet to discover, which could be generating iron in unexpected ways. Moreover, the role of dark matter in this context is another topic of debate. Dark matter, that mysterious substance that does not emit light or energy and makes up a large part of the universe, could be influencing the formation and distribution of iron in galaxies. If this is the case, we would be facing a revelation that could change our understanding of the structure of the cosmos. Observations through modern telescopes have allowed scientists to map the distribution of iron in the universe. However, each new finding raises more questions. Are we really seeing everything there is to see? Science progresses, but the mystery of cosmic iron remains an intriguing part of our journey toward understanding the universe. The search for answers about cosmic iron also leads us to reflect on the creation of new elements in the universe. As we explore further, we discover that nature has surprising ways of creating and distributing matter. The formation of lighter elements such as hydrogen and helium is just the beginning of a much more complex story. As we continue to investigate, we realize that each discovery about iron in the cosmos is another step toward a deeper understanding of the universe. Mysteries push us to question, investigate, and explore beyond our boundaries. Human curiosity is insatiable, and each answer only generates more questions. Ultimately, the mystery of cosmic iron is a reminder that, in the vast universe, there is still much for us to learn. With each new finding, we expand our perception of the cosmos and get a little closer to solving the enigmas that surround us. The search for answers continues, and perhaps one day we will unravel the secret of iron in the universe. What other mysteries await us on this fascinating journey? What would you do if you were told that there are planets that orbit their stars in a direction contrary to what we consider normal? This intriguing phenomenon is known as retrograde exoplanets. But how is it possible for these worlds to follow such unusual trajectories? The answer to this question leads us to explore the fascinating world of astronomy and the mysteries of the cosmos. Retrograde exoplanets are those that orbit in the opposite direction to the rotation of their star. In a typical solar system, planets rotate in the same direction as their star's rotation. However, under certain circumstances, some exoplanets manage to defy this rule. What could cause a planet to take such a strange path? One of the most accepted theories suggests that these planets may have been captured by the gravity of their star. Imagine a scenario where a wandering planet, free in space, encounters a solar system. Its trajectory is influenced by the gravitational force of the star, which could lead it to start orbiting in a retrograde direction. But what does this mean in terms of the forces at play in the cosmos? Another possibility is that the gravitational interaction between planets in a solar system could alter the orbits of these celestial bodies. Think of it this way: if two planets are in close orbits, their gravitational forces could push against each other, causing one of them to shift into a new orbit, even in the opposite direction. But what implications does this have for the long-term stability of a solar system? The existence of retrograde exoplanets also raises questions about their formation. If most planets form in a rotating disk of material around their star, why do some end up in retrograde orbits? The answer may be related to catastrophic events during the formation of the system, such as collisions between young planets that could lead to a reconfiguration of their orbits. We can imagine that these retrograde planets are like the rebels of the cosmos, challenging established norms. But what kind of conditions would be needed for a planet to survive in a retrograde orbit? The answer is that temperature, composition, and distance from the star are crucial factors. A retrograde exoplanet that is too close to its star may experience intense heat, which could lead to its destruction. Moreover, these strange worlds may offer clues about the history of planetary systems. By studying their orbits and characteristics, astronomers can gain valuable insights into how solar systems evolved and the dynamics of their planets. What secrets could these retrograde planets reveal about the formation of our own solar system? Recently, several retrograde exoplanets have been discovered, and each new finding further challenges our preconceived ideas about how planets should behave. One of the most famous is the exoplanet WASP-1, located about 300 light-years from Earth. This world not only orbits in the opposite direction, but also has extreme characteristics that make it a truly unique place. But how are these retrograde exoplanets detected? Astronomers use various techniques such as transit, which involves observing the light of a star as a planet passes in front of it. By studying the variations in light, they can infer the presence of a planet and analyze its orbit. Isn't it amazing how we can gather information about distant worlds just through the light they emit? As our technology advances, the search for retrograde exoplanets becomes more accessible. More powerful telescopes and sophisticated detection methods are expanding our knowledge of the universe. But what other mysteries might be revealed as we continue to explore the cosmos? The existence of retrograde exoplanets also raises questions about the possibility of life on these worlds. While conditions may be extreme, the diversity of environments in the universe suggests that life could adapt in surprising ways. What forms of life might have evolved on these rebellious planets? Reflecting on all this, it is clear that retrograde exoplanets are not just astronomical curiosities. They offer us a window into the complexity of the cosmos and the richness of its history. Each discovery brings us a little closer to understanding how planets behave, how they form, and ultimately how they relate to our own existence in this vast universe. At the end of the day, the exploration of retrograde exoplanets is a reminder that the universe is full of surprises and mysteries. Every answer we find leads to new questions, and each discovery invites us to look up with wonder and curiosity. What other secrets does the universe hold for us? Only time and the perseverance of scientists will tell. What if I told you that there are stars that defy all logic? We are talking about impossible binary systems where two stars orbit so close to each other that, according to our theories of physics, they should have merged millions of years ago. Yet here they are, shining in the vast cosmos. How is it possible that they continue to exist? In the universe, gravity acts as the master of ceremonies of a cosmic dance. Stars attract each other, but in some cases, the spectacle becomes more complicated than we expected. Imagine two stars in an embrace so close that their gravitational forces should have pushed them to merge in a spectacular explosion. However, there they are, flirting with each other with the grace of a pas de deux. What secrets do these systems hold? One of the most fascinating examples of this phenomenon is the system known as Eta Carinae. This stellar duo is so tightly bound that their orbits complete in less than 5 years, and despite their proximity, they have not become a single star. But what lies behind this strange relationship? The answer may lie in the rotation and energy that each star contributes to the system. This exchange of energy could be keeping them apart, defying expectations. Now let's talk about an intriguing concept. Balance. Stars, like everything in the universe, seek a point of stability. However, the stars in impossible binary systems seem to have found a precarious balance. Is this a new form of stellar life that we do not yet fully understand? Are we witnessing a phenomenon that challenges our understanding of stellar evolution? When we observe these systems from Earth, we often wonder what would happen if we could get closer. How would two stars look in such a close cosmic dance? The light they emit overlaps, creating a visual spectacle that could rival any work of art. But despite their beauty, the reality is that these systems are a puzzle that urges us to rethink what we know about the universe. Some astronomers believe that these systems might be more common than we think. Could it be that in the vast ocean of stars surrounding us, there are hundreds of these mysterious duos hidden? Perhaps we just need to look closer. Imagine the possibility that while gazing at the sky, we are witnessing a spectacle full of untold stories. Moreover, these binary systems could offer clues about how stars form. What happens when two stars meet on the path of life? Does their closeness push them to merge, or does it give them the opportunity to share their existence in a delicate balance? Every answer we find leads us to new questions, creating an endless cycle of curiosity. One fascinating aspect of these systems is how they challenge the notion that stellar fusion is the inevitable fate of all stars that meet. Instead of becoming a supernova, some seem to find a way to coexist. Which raises an intriguing question. Are we witnessing the evolution of a new type of star? Can these binary systems be a window into the future of our understanding of the cosmos? It's not just about stability. We must also consider the effects these stars have on their surroundings. Being so close, their gravity can influence other nearby stars and celestial bodies. How many stellar systems have been shaped by the presence of these cosmic duets? The influence of a binary system could be the driving force behind the formation of new stellar systems. And let's not forget the importance of observation. With each new telescope launched into space, like the James Webb Space Telescope, we get closer to unraveling these mysteries. Every image we capture is a step toward understanding these phenomena. What revelations await us in the near future? Technology is advancing rapidly, and each day new doors to the unknown are opened. Stars that defy logic are not only a visual spectacle, but also a reminder of the vastness of the universe and how little we truly know. Each discovery invites us to question our assumptions and explore beyond the limits of our knowledge. What mysteries are waiting to be revealed in this vast universe we inhabit? So as we look up at the sky, let us remember that each star has its own story, each one a chapter in the book of the cosmos. Impossible binary systems are just one of the many mysteries surrounding us, and each one invites us to keep exploring, to keep asking, and to keep marveling at what the universe has to offer. The search for answers never stops, and each question is just the beginning of a new adventure in the vast and enigmatic universe we inhabit. In the vast immensity of the cosmos, there are structures that challenge our understanding of matter and energy. Among these wonders are the so-called cosmic chains. But what exactly are they? Imagine enormous filaments connecting galaxies, forming a network that is larger than anything we have been able to conceive. These chains are truly astonishing and raise numerous questions about how matter is organized in the universe. Have you ever wondered how these gigantic structures form? Cosmic chains seem to be the result of a combination of gravitational forces and the expansion of the universe. But what really intrigues astronomers is the way these filamentous structures intertwine and distribute throughout space. Why are some galaxies connected to each other while others appear to be completely alone? The first time these chains were identified was thanks to the observation of several galaxies that seemed to align in strange patterns. As scientists have explored further, they have discovered that these chains are not only fascinating for their shape, but also for their size. Some of them span millions of light years. It's as if the universe is mapping its own history, connecting distant points in a cosmic tapestry. However, cosmic chains are not simply a visual phenomenon. They play a crucial role in the distribution of matter in the universe. The way galaxies cluster in these chains can influence how they interact with each other. From galaxy mergers to the formation of new stellar systems, this raises another intriguing question. How do these structures impact the evolution of the universe? As scientists study these chains, they encounter another mystery: dark matter. This form of matter, which does not emit light and is nearly invisible, seems to be present in large quantities within these structures. Could it be that dark matter acts as a scaffolding that supports and guides the formation of these chains? The answer remains elusive, but each discovery brings us a little closer to understanding its role. The study of cosmic chains also leads us to consider the early history of the universe. During the time of the Big Bang, the universe was in an extremely hot and dense state. As it expanded and cooled, matter began to clump together due to gravity. But what caused some areas to densify more than others, forming these chains? The answer may lie in the small density fluctuations that occurred in the early moments of the universe. There are theories suggesting that these chains could be the result of complex processes involving gravity, radiation, and dark matter. By linking galaxies and clusters of galaxies, these chains may have influenced the formation of larger structures, creating order in the apparent chaos of the universe. Are we talking about a cosmic design, or simply a game of probabilities in a vast, endless space? As telescopes advance and observation methods improve, scientists are beginning to uncover more about these chains. Structures have been found that seem to encompass hundreds of galaxies. What if I told you that some of these chains are so well defined that they appear to be paths that galaxies follow over time? This suggests that in a sense the universe has its own architecture, despite all we have learned. Many questions remain unanswered. For example, how do interactions between galaxies in these chains affect the formation of new stars? And what about the galaxies located at the ends of these chains? Research continues, and each new finding only adds more layers to this intriguing cosmic mystery. Astronomers are increasingly convinced that understanding these cosmic chains is key to deciphering the history of the universe. Each chain could be a book narrating how matter has grouped and evolved over billions of years. But will it be possible to read all the pages of this story? Ultimately, the study of cosmic chains reminds us that the universe is a place full of surprises. Each discovery leads us to new questions, and each answer seems to open the door to a new enigma. The search for truth is endless, and in this vast ocean of information, cosmic chains remain one of the most captivating mysteries. So, as we gaze at the starry sky, perhaps we should remember that we are not only seeing stars and planets, but also the intricate networks that connect everything in the universe. Cosmic chains are a reminder that the cosmos is a dynamic place, full of secrets waiting to be discovered. And although each answer may lead us to more questions, that is precisely the essence of scientific exploration and human curiosity. Who knows what other mysteries the universe has in store for us in the future? In the vast universe, there is a mystery that leaves us perplexed: dark matter. What is this enigmatic substance that seems to be everywhere, yet we cannot see or touch? If we look around us, we can observe stars, planets, and even galaxies, but there is something that doesn't fit. Why do galaxies rotate at such high speeds that, according to our laws of physics, they should disintegrate? The answer to these questions may be hidden in dark matter. Dark matter does not emit light or energy, making it invisible to our telescopes. However, its presence is felt through gravity. Imagine you are at an amusement park watching a group of people on a roller coaster. You can see how they move, but if an invisible force pushed the roller coaster forward, that would give you clues about something you cannot see. This is how astronomers discovered the existence of dark matter, by observing how galaxies behave. But how do we know that dark matter is not simply cosmic dust or some other form of visible matter? There is multiple evidence pointing to its existence. For example, When studying galaxy clusters, scientists noticed that the amount of visible matter is insufficient to explain the gravitational force acting on them. So why do galaxies stay together? The answer seems to lie in a form of matter that we cannot see. Have you ever wondered how much of our universe is composed of this dark matter? Recent estimates suggest that around 95% of everything that makes up the cosmos is dark matter and dark energy. An even more mysterious form that is also at play. In comparison, the matter we know, the one that forms stars, planets, and everything we see around us, represents only about 5%. How can it be possible that most of the universe is made up of something we do not understand? Scientists have proposed several theories about the nature of dark matter. One of the most popular suggests that it is composed of subatomic particles called WIMPs, which interact weakly with massive particles. However, despite years of research, we have yet to detect them directly. What if dark matter is not just a form of matter, but something completely different that challenges our current understanding of physics? As we delve deeper into this mystery, we find that dark matter may also be related to the formation of structures in the universe. Computer simulations indicate that without dark matter, galaxies like ours could not have formed. What does this mean for us? That the history of the universe is closely tied to this invisible substance. The theories about dark matter also open the door to fascinating questions if we ever manage to understand what it is. Could it help us unveil other mysteries of the cosmos? Imagine discovering that dark matter is the key to understanding phenomena like the accelerated expansion of the universe. The search for answers could lead us to a new paradigm in physics. In an attempt to solve this enigma, underground laboratories and cutting-edge telescopes have been built to try to detect signals of dark matter. But why is it so difficult? The answer lies in the fact that, unlike the particles we know, dark matter does not interact with light. This makes it extremely elusive and challenging to study. However, despite these obstacles, interest in dark matter continues unabated. Every year, scientists make new discoveries that may bring us closer to understanding its nature. Could it be that, in the not-so-distant future, we will unveil the secrets of this substance and perhaps rewrite the textbooks of physics? The mystery of dark matter also raises profound philosophical questions. If most of the universe is composed of something we cannot see, what does this imply about our understanding of the cosmos? Science has advanced significantly, but there are still limits to what we can know. This leads us to reflect on our position in the vast universe and the relentless pursuit of knowledge. Dark matter, though invisible, has a real impact on our existence. Its influence is felt in the formation of stars and galaxies, in the very structure of the universe. Without it, our understanding of the cosmos would be completely different. Are we ready to accept that there is much more than we can perceive? Finally, as we continue exploring and seeking answers, dark matter reminds us that the universe is full of mysteries. Each discovery leads us to new questions and invites us to keep investigating. The search for dark matter is a quest for truth, a journey into the unknown that unites us all in the fascinating adventure of knowledge. What other secrets does the universe hold for us? The answer is still in the air, waiting to be discovered. As we look out into the vast and mysterious universe, one cannot help but feel small and, at the same time, deeply intrigued. Each star that shines in the night sky tells us a story, but there are so many unanswered questions. What secrets does the cosmos hold? Why is there so much that we still do not understand? The quest for answers to these mysteries leads us to reflect on our own existence and our place in the universe. We have explored enigmas that seem straight out of a science fiction novel, yet they are realities that challenge our understanding. For example, what about dark matter? A substance we cannot see, yet it influences the gravity of galaxies. How is it possible that something that emits neither light nor energy has such a significant impact on the structure of the universe? The search for this elusive matter forces us to rethink what we know about physics. And when thinking about exoplanets, it is fascinating to imagine distant worlds, some of which may be radically different from Earth. Do planets covered in diamonds exist, as some suggest? These speculations make us question the diversity of the cosmos and the possibility of life in places we have never imagined. What would it be like to live in a world where the sky is made of shining crystals? The mysteries of gravity also intrigue us. Why do some galaxies seem to be moving away at speeds we cannot explain? The expansion of the universe is a known phenomenon, but the rate at which it is expanding is perplexing. Could it be that there are unknown forces at play pushing galaxies toward a fate we do not yet understand? The idea of cannibal galaxies is another that sparks curiosity. How is it possible for one galaxy to devour another? What appears to be an act of cosmic aggression is actually part of a natural process that has been occurring for billions of years. What does this tell us about the evolution of the universe and life itself within it? And on this journey of exploration, we also find the cosmic chains, those colossal filaments that connect galaxies to one another. What role do these filaments play in the structure of the universe? They could be the key to understanding how galaxies form and evolve, and their discovery changes our perspective on the interconnectedness of all that exists. The nature of stars is equally fascinating. Some of them mysteriously disappear, leaving astronomers puzzled. Where do they go? Could they be gateways to other worlds or dimensions? The disappearance of stars raises questions about life and death in the cosmos, blurring the line that separates these two states. Another astonishing mystery is that of evaporated planets. Imagine a world slowly dissolving, consumed by the radiation of its star. What life might have existed there before its disappearance? This phenomenon reminds us of how fragile life is and how the cosmic environment can unpredictably alter its course. In our journey through the universe, we must not forget the beauty of cosmic dust. These tiny particles, which seem insignificant, are the building blocks of life. Could they be responsible for seeding life on Earth? The idea that everything we are comes from stars that exploded eons ago is a profound thought that connects us to the cosmos. And as we contemplate super-Earths, those planets that are larger than our home but smaller than Neptune, we wonder, what secrets do they hide? The formation of these worlds remains a puzzle for scientists, who seek to understand how they are created in such a chaotic environment as space. The question of whether there is life on moons like Europa or Titan also fascinates us. These moons, covered in ice, could harbor hidden oceans beneath their surfaces. What forms of life might exist in those depths? The possibility that life is not limited to our planet is an idea that invites us to explore beyond our known boundaries. Finally, as we reflect on all these mysteries, we realize that the universe is a vast book filled with blank pages yet to be written. Each discovery brings us one step closer to understanding our existence and the place we occupy in this immense cosmic stage. The quest for answers is never-ending, and each answer brings new questions. This is how science progresses, driven by curiosity and the desire to understand the unknown. So as we gaze at the stars, let us remember that the mysteries of the universe are also a reflection of the mysteries within us. The question is not just what is out there, but also what it all means for us as human beings. The adventure of discovering the secrets of the cosmos has only just begun, and we are all invited to be a part of it.